So in the wave optics, we'll be dealing with an interference of the light, Huygens principle, YDSC, and the resolving power of the telescopes and the microscopes. So these are the most important concepts that are occurring in the examination. In YDSC experiment, Young's double slit experiment, the separation between the two coherent sources has been halved. Separation between the two coherent sources means initially d1, small d1 is equal to d. Now it has been reduced to d2 is equal to d by 2. And the distance between the screen and the sources has been doubled. That means initially it might be the d. Now it is been d2 is equal to double, that is 2 times of the capital D. So what will happen to the fringe width? What is the relation of the fringe width is? That is beta is equal to lambda into capital D by small d. So new values beta dash is equal to lambda into 2 into capital D by small d by 2, or it is 4 times of the beta. So that means your fringe width will be increased by 4 times. In a double slit experiment, when light of the wavelength 400 nanometers is used, lambda has been given, and an angular fringe width of first maximum. This is the one thing important. First maximum is occurring at a place at a distance of 1 meter away. That is capital D is, that is theta. Angular fringe width he has given. What will be the angular fringe width? The first same maximum. If the entire setup is immersed in the water, what will happen if you immerse in the water? Wavelength will be changing or beta will be changing. So angular fringe width can be written as an, that means for example, this is your angular fringe width conditions. This is the complete fringe, either a bright or a dark. This is the one beta. This is your theta value. It is your capital D. For theta being the very small value, or tan theta will be equal to the almost theta, which is equal to the beta by capital D. So initial value he has given theta. Now the new value theta dash is equal to, since it is immersed in water, beta will become as an beta by mu into capital D, which is equal to the theta times by mu. What is the initial value of the angular fringe width is 0.2 degrees by, this will be the 4 by 3. So this comes out to be the 0.15 degrees. That is 0.6 by 4. It will be 0.15 degrees. Next, in a YDSC experiment, if there is no initial phase between the light from the two slits, there is no phase differences there. A point on the screen corresponding to the fifth minimum has a path difference. He is asking what? Delta x for fifth minimum. So delta x for the fifth minimum, in the sense, what is the minimum formula for the delta x? Delta x is equal to, it will be the 2n minus 1 into lambda by 2 if I take the n values from the 1. So now substitute the value of the n value fifth one, which is equal to the 10 minus 1 into lambda by 2. That is equal to the 9 lambda by 2. So this should be your for the fifth minimum condition. There is no initial phase difference, extra path difference will also be not there. In Young's double slit experiment, the separation D between the slits is 2 small d he has given. Wavelength lambda has been provided, capital D between the slits is also given. It is found that the angular fringe width of fringes is 0.20 degrees. The increase in the angular fringe width, he wants to increase the angular fringe width from 0.20 to 0.21, with keeping the lambda and capital D same, but he wants to change the separation between the slits. As just in the earlier case, I have written that is theta is equal to beta by capital D. This is also equal to the lambda by small d. Since beta is equal to lambda into capital D by small d, from this relationship we can see it. From here, So theta 1 by theta 2 is equal to, this should be your d2 by d1. Theta 1 is 0.20 by 0.21 is equal to d2 is the value we need to find, and d1 value is 2 mm. So from here, it will be the 0.20 into 2 by 0.21, which is equal to the d2. Okay, so these are your relationship keys. So on solving this one, obviously it will be less than 2, just less than 2. That means it should be somewhere around 1.9. You should be getting it. Next case, the ratio of the resolving powers of the optical microscope, the wavelengths he has given. So what is the relationship between the resolving microscope? So resolving power of an resolving power of microscope is, so microscope can be written as an, it is 2 mu of sine theta by lambda. So that means your resolving power is inversely proportional to the lambda. Or shall I write the relationship as an resolving power R1 by R2 is equal to, that will be lambda 2 by lambda 1. So lambda 2 is how much? 6000 angstroms by, it is 4000 angstroms, which is equal to the 3 by 2. Okay, next one. Young's double slit experiment is first performed in the air and then in a medium other than air. It took that eighth bright fringe of the medium lies where the fifth dark fringe lies in the air. Okay, that means the distance of the fifth dark fringe in the air, that is y of the fifth dark. Now on introducing the medium, now what you're getting at the same distance, eighth bright in medium. So this is the information he has given. What is the formula for the dark fringe? 2 in 2n minus 1 into lambda into capital D by small d. And when we have introduced the film, that is lambda will be changed by mu, lambda by mu times. So it will be the lambda into, that is 8 lambda into capital D by mu into small d. Here the n value is how much? 5. So when I replace and just try to solve this one, this will become as a 9 lad capital D small d, capital D small d. This also can be removed here. So this will be the 9 minus, what is the value is? 10 minus 1, 9 by 2d by 2 is equal to 8 by mu. So when solving this one, mu is equal to, you should be getting it as a 16 by 9. 16 divided by 9, it should be the 1.78. Like this should be your answer. Next, two Polaroids P1 and P2 are placed with their axes perpendicular to each other. Unpolarized light of intensity I0 is been falling on the first Polaroid. And a third Polaroid P3 is kept in between the P1 and P2 such that it makes an angle 45 degrees to this one. That means your first Polaroid P1 might be like this, whose axis is perpendicular, that is like this, which is making an angle, it is purely vertical, 0 degrees. So as soon as an unpolarized light is been falling on the first Polaroid, the intensity that comes out will be the I0 by 2 from the first one. Now, so with respect to the second one, here he has placed a P3 here. So how he has placed it, its axis makes an angle 45 degrees with the P1. Now this is your I1, which falls over here as it comes out as an I2. So according to the Mule's relationship, I2 is equal to I1 into cos square of 45 degrees. So I1 is nothing but the I naught by 2 into this will be the 1 by 2, which is equal to the I naught by 4. Now the same light, which is I naught by 4 intensity, will falls on the second Polaroid, which is actually perpendicular for the initial case, like this. So that means with respect to P3, it is making an angle of 45 degrees again. So again apply. So final value is going to be your I2 is falling on this one. So I3 is equal to how much? I2 times of this is cos square of 45 degrees. I2 is again I naught by 4 and this will be the 1 by 2. So your final intensity will be the I naught by 8. So remember this one, whenever unpolarized light falls on the Polaroids, then its intensity reduces to half. In a diffraction pattern due to the single slit of the width A, the first minimum is observed at an angle of 30 degrees when light of the wavelength 5000 angstroms is incidented on the slit. First secondary maximum he is asking will be at which angle it can be. Okay, according to the diffraction pattern, that is slit width A sine theta is equal to lambda. So initial angle is 30 degrees. In the sense A into sine 30 is equal to lambda, or from here A is equal to 2 lambda. So we have got the width of the slit. Now for the secondary maximum, this is for the minimum condition, it will be n lambda. In the diffraction, the formulas will be reversed. Secondary maximum means it should be the A sine theta should be equal to the 3 by 2 times of lambda, or generalized formula is 2n minus 1 into lambda by 2 for the maximum in diffraction. So now A value is 2 lambda into this is sine theta is equal to 3 by 2 lambda. Lambda can be removed. Sine theta is equal to 3 by 4 in the sense the new value, that is the theta, will be equal to the sine inverse of 3 by 4. So this is our relationship case. Next, the intensity at the maximum in a YDSC. Young's double slit experiment is I naught. Distance between two slits is D is equal to this. Okay, 5 lambda he has given. Okay, so let's write down the information. Small d is equal to 5 lambda and capital D is equal to 10 times of small d he has given. And what will be the intensity in front of the one of the slits of the screen, please? What is the distance in front of the one of the slits means? Suppose these are your slits S1 and S2, and this is your screen. In front of one of the slits means your Y value indirectly he is providing it to be the D by 2, exactly half of this one. So if, and moreover the maximum intensity is I naught he has provided. What will be the intensity at this particular point P, we need to find it. So to find that particular intensity at that particular point, intensity at the Y, if I need to find it out, I is equal to, that is I naught into cos square of 5 by 2. For this one, I need the phase difference is going to be how much? So to find out the what is the phase difference in this case, so we have got the information to find path differences and all these things are there. We have got the Y relationship at that particular thing. Y value is equal to D by 2. So how do you go for this particular path difference here? So as we know that from the diagram also you can see that this one delta x can be written as an actually d sine theta. Since sine theta and tan theta are the very small, almost equal for the small angles. So I would like to replace the tan theta terms here. So d into, this is going to be the y by capital D. This is the distance of the angle. Okay. This is your theta. So y by capital D, I have replaced this. small d into y by. So, but what is the y value is d by 2. Capital D is 10d. So d into d by 2 by 10 times of the d, and which is equal to how much, sir? This is going to be the d by 20. So d by 20 is there for us. What is the d by 20 is also there. So I need to get it in terms of the lambda terms there. So, but what is the value of the d is 5 lambda, substitute. So 5 lambda by 20 is equal to, so we have got the delta x is equal to lambda by 4. And we know the relationship between the phase difference and the path difference. Phase difference is equal to 2 pi by lambda into path difference delta x, which is 2 pi by lambda into path difference. We have got it as an lambda by 4. These two goes off, it will be pi by 2. Now, when you put it down in the intensity conditions, that is the angle between the two intensities is 90 degrees. If I go for the intensity relations, whether both of them are the same or not, he has not mentioned in the question. So I maximum can be written as, and this is I1 plus I2 plus 2 I1 I2 in this sense, that is 2 root of, this is root I1 root I2. Cost value is going to be something maximum, or from this one we can say that I maximum, and in this question he has mentioned I maximum is equal to 4 times of the I, where I is an intensity of individual waves. Or from this one, I is equal to I naught by 4, since I1 is equal to I2 relationship. Now put it in the IY, sir. So IY is equal to I1 and I2 are same. So I1 plus I2 plus 2 I1 I2 cos theta is how much? Pi by 2. And that comes out to be your I naught by 2. This will be your intensity at that particular instant. Next, in the interference pattern, it is obtained that two coherent light sources having the intensity ratio as I1, and that is I1 by I2 is equal to N. Okay, in the interference pattern, ratio of I maximum minus I minimum by I maximum plus I minimum. So this is asking the visibility region, visibility thing. So I first will go for the I maximum by I minimum value. Let's try to find it out first. What is I maximum by I minimum? Directly I can write it as an root I1 plus root I2 whole square by root I1 minus root I2 whole square. Take out the I2 common and substitute in this case. So it will become as an root over I1 by I2 plus 1 whole square by root over I1 by I2 minus 1 whole square. So this can be written as an root n plus 1 whole square by, it will be the root n minus 1 whole square. This is the situation, please. Now from the, we have got the I maximum and I minimum. Now put it down in the I maximum minus I minimum by I maximum plus I minimum. The same thing can also be written as, that is I maximum minus I minimum in minimum intensity by maximum intensity plus minimum intensity. Take out the I minimum common and write it in the same order. This will become as an I maximum by I minimum minus 1 by, this is I maximum by I minimum plus 1. Now substitute the value of the I maximum by I minimum in the relationship. That will come out as a root n plus 1 by root n minus 1 whole square minus 1 by, this will be again root n plus 1 whole square by root n minus 1 whole square plus 1. This is our relationship. So solving this one, you should be getting it as in taking the LCM and all these things. Here the plus sign is there. So in the numerator, we should be left with 4 root n. And in the denominator, we should be left with 2 into n plus 1. Or it will be 2 root n by n plus 1. This is our relationship. Next one. For a parallel beam of monochromatic light of wavelength lambda, diffraction is produced by a single slit whose width is a. In the order of wavelength of the light, if d is the distance between the screen and the slit, the width of the central maximum is asked. What do you mean by width of the central maximum? So try to remember this formula of the width of the central maximum. If this is your screen, then the central maximum will be spread out like this. So that means if I draw a graph, it will be like this. Here it comes down to the minimum and finally it will be gradually decreased. And on this side also it will be gradually decreased. This is your width of the minimum. This is your y and this is also y. Since this is theta and this is also theta. So he is asking this distance, width between these two locations he is asking. That means 2y. So we know that a sine theta is equal to lambda for the max condition. This one we have written. And from minimum conditions because the distance between the extreme minimums is the maximum. So from this one, sine theta can be written as an lambda by small a. So since thetas are very small, I can also write the same relation as in terms of the tan theta. Tan theta is equal to y by capital D. Opposite side by this is your distance between the slit and the screen. And this should be equal to the lambda by a. From this one, directly you can get it as an y is equal to lambda into d by a. But we need the width of the central maximum. Width of central maxima. So width of the central maxima is 2y. So that implies your answer will be 2 lambda into capital D by a, where a is the width of the slit. 2d lambda by a. This is our relationship. Next one. In Young's double slit experiment, two slits are 1 mm apart. That is, he has given the distance between the two slits, small d, and screen is placed 1 meter away there. A monochromatic light of the wavelength 500 nanometers is used. When what will be the width of the each slit? He is asking. Each slit for obtaining the 10 maxima of double slit within the central maximum of single slit pattern. So what should be the width of each slit he is asking? For what? Obtaining 10th maxima in the double slit, that means 10th maxima in YDS within the central maximum region of the single slit pattern. So in the central region only we have to get 10 fringes there. He has given the small d and all these things. So what is the width of the central maxima? Just now I have written width of central maxima is equal to 2 into capital D into lambda by A. So in the same region, he is asking he should get 10 fringes. Okay, so that is slits obtain the 10th maximum, that is 10 beta he is asking to get over there. Implies you can write it as a 2d into lambda by A should be equal to the 10 into beta formula is lambda into capital D by small d. Lambda into this one you can remove here and we can say that fringe width is equal to 2 into small d by 10, or you can also cancel them in either case. 2 into small d is how much? This is 1 mm apart, 1 into 10 to the power of minus 3 by 10. So that comes out to be the 2 into 10 to the power of this one, that is -4, or we can go for it 0.2 millimeters. So this is the situation, please. Next one, at the first minimum adjacent to the central maximum, the first minimum which is adjacent to the central maximum of a single slit diffraction pattern, the phase difference between the Huygens wavelet from the edge of the slit to the wavelet from the midpoint of the slit. So he is asking what is an phase difference. So this is the situation. So if the total width of the slit is going to be your A, then he is asking what's the phase difference between the midpoint of the slit and the edge of this one. So this distance should be how much? A by 2. When this divides into the even multiples, then obviously you should be getting it as an sum, maximum conditions. So that means A by 2 sine theta is equal to. So first minimum he is asking. That means what is the value of the first minimum in the case? Lambda by 2. So A value slit width is going to be the, if I this can be written as an A into sine theta is equal to. So we'll be getting it as an 2 cancels, it will be lambda only. So this is the value of your delta x. Since we have got the delta x, substitute in the phase difference. Delta phi is equal to 2 pi by lambda of delta x, which is 2 pi by lambda into delta x can be written as an simply lambda. Both of them will be cancelled, and your phase value is going to be the 2 pi. Okay, so it is lambda by 2, sir, right? Okay, so lambda by 2 in the sense 2 will also go. So phase difference is going to be the pi, that is 180 pi radians. This is the one. Two Young's double slit experiments, the widths are in the ratios. So we know that I1 by I2 is equal to width ratios. W1 by W2, intensity is proportional to the width, and width is proportional to the square of the amplitude conditions. So this width value he has given it as an 1 by 25. So from 1 by 25 only. So now from this one, we can write the ratio of the amplitudes A1 by A2 is equal to 1 by 5. Or I can replace your A2 is equal to 5 times of A1. Because we need to go for the I maximum by I minimum. So what is the formula for the I maximum to the I minimum is A1 plus A2 whole square by, this is A1 minus A2 whole square, or A2 minus A1, whatever the greater value minus smaller value. So if I replace this one, this will become as an A1 plus 6, this one 6A1, A1 minus A2 is this one 4A1 with a negative sign. Obviously there is a square on them. So it will be how much? 3 by 2 whole square. In the sense it should be the 9 by 4. So this should be your options. Next, a beam of wavelength of the light is equal to 600 nanometers from a distant source falls on a slit, single slit 1 mm width. Small d he has given, and wavelength also he has given. Distant source falls on the single slit, and the resulting diffraction pattern is observed on the screen is 2 meters away, that is capital E. Distance between the first dark fringe on the either side of this one, distance between the first dark fringe, or it should be the end of the first bright, the distance between the two darks, like this it will be coming out. It is nothing but the starting point of the dark regions or ending points of the bright region. Just now we have derived what is the fringe width. Formula of this one is going to be the 2 into capital D lambda by small d. So now substitute this one, that is width of central bright region or bright fringe. So how does this can this all the values substitute 2 into capital D is 2 meters away, lambda is 600 nanometers, or it is 6 into 10 to the power of minus 7 meters. It comes out to be fine. So D value I have written, this one also I have written by small d. What is the small d value is 1 mm. In the sense it will be 1 into 10 to the power of minus 3. Now we need to solve this one, that is 24 into 10 to the power of minus 4, or that can be written as an 2.4 into 10 to the power of minus 3, or 2.4 mm. So this is our relationship, please. Next one, in YDSC, the intensity of the light at a point on the screen where path difference is lambda is k. So intensity value at a given point. He has named it as an k. Okay. The YDSC is the point on the screen where the path difference is lambda. So if path difference is lambda, this has to be the maximum, because for the minimum path difference will be of order lambda by 2, 3 lambda by 2, like that. So intensity at a point of path difference lambda by 4, he is asked. So if the path difference is lambda by 4, what will be the phase difference is? What can be the phase difference? That means delta phi is equal to 2 pi by lambda into, this will be your, how much ma'am? Lambda by 4. These two goes up, goes for 2 times. When I substitute in the formula, that is I is equal to I maximum is k. That is the one we need over here. K into this is cos square of pi by 2. So change in the phase is how much here, pi by 2, or there is already 2 will be there, that is k into cos square of, so it will be pi by 4, or it can be the, how much it should be, so root 2 times of this one, then it will be written as an k by 2 times root 2 will be happening over here, because cos 45 is 1 by root 2, 1 by root 2 whole square is 1 by 2. So next section, in YDS Young's double slit experiment, the slits are separated by a distance of small d. He has been illuminated by the photons of the wavelength 240 regions. He has been incidentating over there. At what minimum distance from the common bright central fringe, that is the capital D, from the slit, where the bright fringe from one interference pattern coincides with a bright fringe of other. That means your y1 of the first wavelength and y2 of the second wavelength should coincide. Both of them should be same. That means n1 lambda 1 is equal to n2 lambda 2. So from this one, n1 by n2 is equal to lambda 2 by lambda 1. In the sense, this is 12,000, 10,000 by 12,000. So let me finish 5 is to 6 ratio. They might be in this particular ratio. That is the nth. That means in the ratio comparison, if I go, it should be the fifth fringe of the n1, and it should be the what is another fringe, and it should be the sixth fringe of the second with the second lambda. So that means at the same distance y value, as I have equated y1 and y2, at the same position y1 and y2, the fifth of the first lambda or the sixth of the second lambda should be coincide. So as we have got in the ratio, that means I'll go for the y. Y is equal to delta x into capital D by small d. Delta x can be written as an n1 lambda 1, directly you can write it, into capital D by small d. Number of the fringes is going to be the fifth fringe. And what is the value of the lambda 1 for the first case is 12,000. 5 into this is 12,000 into capital D is 2 meters. by small d is 2 mm, 2 into 10 to the power of minus 3. So these are your conditions, sir. So when you solve this one, so these two goes off here, this will be the 60, or so if I take it to the numerator, this one, that is 6 into, you should be getting 10 to the power of minus 3, or it will be the 6 mm in this situation. Next, in YDSC experiment, the distance between the slits in the screen is doubled. So what will happen to the fringe width? Fringe width is proportional to the lambda into capital D by small d. So your new change beta dash is equal to the 4 times of the beta. So next question, please. The diameter of an human eye is 2 mm. What will be the minimum, that means size of the aperture, minimum distance between the 2 points? So let the 2 points are being there like this. This is the point 1 and this is the point 2. So what is the minimum distance he is asking? Let it be the yes something. So what should be the minimum distance between these 2 points so that they can see them, so they can resolve them, which are at a distance of 50 meters apart. So this is point 1 and this is point 2. Yes value we need to write. So length of the arc S is equal to radius into d theta. Radius is equal to 50 into d theta. So we need to first find out that d theta is going to be how much. For that one, I'll go for the resolving limit. That is 1 by d theta is equal to nothing but an d by lambda, or d theta is equal to lambda by d. So d theta is equal to lambda divided by small d. So lambda is equal to 5000 angstroms by small d is 2 mm, 2 into 10 to the power of minus 3. So that comes out to be how much, sir? When I put down in the S relationship, please. So S is equal to R is the distance which is 50 meters or centimeters. I'll just take this one into d theta value. This is going to be the 5000 into 10 to the power of minus 10 angstroms we are writing by small d is 2 into 10 to the power of minus 3. Right, sir? So these are your values. We need to substitute them, please. 25 by 2, it should be somewhere around 1.25 centimeters. So this should be your answer. A parallel beam of monochromatic light of wavelength 5000 angstroms is incident normally on a single narrow slit of the width this much. So slit width is narrow. Single slit, that is, if I take it as a also, we can no problem. The light is focused on the convex lens on the screen placed on the focal length. The first minimum will be formed for an angle of diffraction. How much? So according to the diffraction, A sine theta, that is L. Part difference is equal to L lambda. First minimum, since he is asking 1 into lambda. So from this one, sine theta is equal to lambda by A. What is your lambda value? Is 5000. 5000 into 10 to the power of minus 10 angstroms only he has given by A. So coming to the A, what is the width of the slit? This one is going to be the width, so that is 1 into. You can go for it as an, since it is in the mm, let me also convert it into the SI 0.001 into 10 to the power of minus 3. So this value is going to be coming out. Obviously, this is minus 6 is 7, 10 power minus 7 will be left over in the numerator. So it will be the 0.5. And when, if it is 0.5, that means 1 by 2. That means theta is equal to how much? 30 degrees. Since theta is 30 degrees, this is what he is asking, right? So now this is your option. Next one. In YDSC experiment, carried out of the light of the wavelength lambda is equal to 5000 angstroms. And distance between the slits is small d he has given. Screen is 200 centimeters from the slits. The central maximum is at x is equal to 0. Third maximum will be at x equal to. Is asking the third max. Okay. So if I try to replace that one, that is delta x is equal to, we can go for this as an n lambda into this. I'll write capital D by small d. Okay, or else you can put fringe width terms or anything. Delta x is equal to, I have written in another format. So now substitute all the values here. So what is an nth value? Third maximum. That means n value should be 3 into lambda value he has provided. That is 5 into 10 to the power of minus 7 into what is your capital D value is 200 centimeters. 200 into 10 to the power of minus 2 by small d value. What is the small d is 0.2 mm. Since it is 0.2 mm, we can write it as in directly 2 into 10 to the power of minus 4. So obviously this goes for 100 times and these two will be removed. And this is 15 into 10 to the power of minus 7 plus 4, which will be the minus 3. Okay, so or else I can write it as an 1.5 centimeters. I can relieve it like this. So this should be in the centimeters term. This is also in the, all the units are in centimeters only. Next one, the ratio of the intensities of the waves are given by, that means I1 by I2 in an interference pattern are 4 is to 1. The ratio of the amplitudes is asking, that means A1 by A2 is equal to 4 by 1 whole to the power of 1 by 2, which is 2 is to 1. Right, sir? Next one. In YDSC experiment, two coherent sources are placed at a distance of. He has given the small d apart and the fringes are been observed 1 meter away. Capital D is equal to 1 meter. It produces what? So what it produces? Dark fringe at a distance of 1 mm. That means Y from the central region. Put it in the formula. So Y is equal to your delta X into capital D by small d. Y is equal to 2n minus 1 into Y value is 1 mm is equal to, this will be the, so second dark he is asking, that is 2 into 2 minus 1 into wavelength. That is the one we need to determine, and capital D is 1 meter by small d is 0.9 mm. Now cross multiply this one. So this will be the 9 into 10 to the power of, there is a minus 3 minus 3 minus 6 and 0.9 minus 7 is equal to 4 minus 1, 3 lambda. From this one, can we go for the lambda value, sir, here? What will be the lambda here? Lambda is equal to, that is 9 into 10 to the power of minus 7 by 3. So you can, this is by 2 also there, sorry, this I have left over here. So by 2 will also be there. Okay, so now we need to go for the basic thing. The basic answer is lambda by 2d, right? Since it's a dark fringe. So lambda by 2d we need to be substituting over there. So from that one we can get the lambda is equal to this much. So your better answer is going to be nearby to the situation. This will be the 0.6 into 10 to the power of minus 5 centimeters. In YDSC Young's double slit experiment, the fringe width is found to be 0 point, that means beta is equal to 0.4 mm. If the whole apparatus is immersed in a liquid of refractive index 4 by 3 without disturbing the geometry mu fringe width, that means beta dash is equal to beta by mu. Directly you can write it 0.4 by, this will be the 4 by 3. That comes out to be the 0.3 mm. So if it is immersed in the fringe width reduces by mu times. The YDSC Young's double slit experiment is performed with a blue light and a green light. Green light value he has given, blue light is not given, but we can have it, no problem. If x is the distance of the fourth maxima from the central one, then he is asking what is what. So y is equal to n into lambda into capital D by small d. Distance x annadu I have taken it as an y. So from here y is proportional to the lambda. N, D, all of them are the constants. So that means in from this relation you can say that lambda of the blue is less than the lambda of the green. So y of the blue is less than the y of the green. So this is your situation. So that is x of the blue E should be, this is the one, instead of the x we have taken it as an y. So by this